Today we're going to learn how to balance chemical equations. So first and foremost, we know that we've been learning about the law of conservation of matter, or another word for this is the law of conservation of mass, which says that matter is neither created nor destroyed in a chemical reaction, it only changes form. So because of this, we have to have the same number of each type of atoms on both sides of the equation. Because again, matter cannot be created or destroyed. So for this reaction right here, I see that I have one carbon atom on the reactant side, one carbon atom on the product side. I have two oxygens on the reactant side and two oxygens on the product side. So here, matter is not created. I don't all of a sudden have more oxygens over on the product side. It's also not destroyed. I don't have less oxygens on the product side than I had on the reactant side. So it obeys the law of conservation of matter. So the reason that we balance equations is that because of the law of conservation of matter, we have to have the same number of atoms on each side of a chemical equation. So some rules for this. Number one, we want to determine the correct formulas for all the reactants and products. This is like if it's written out in words or something like that, you want to make sure that you have the correct formula. Number two, you want to write the skeleton equation, and this is just the chemical reaction in chemical formula form. Number three, you want to determine the number of atoms for each element. And I like to actually write them under each compound as well. I'll show you what I mean by that in a second. Number four, you then want to balance the elements one at a time using whole number coefficients in front of the elements or compounds. So remember, those coefficients are those big numbers that are in front of the compound. You never want to put the coefficients in the middle of a chemical compound because that just doesn't make sense. And then you also never ever want to change the subscripts because if you change the subscripts, you're changing the chemical compound, and you don't want to do that either. Number five, you want to check that each element is equal on both sides. And then number six, we want to make sure all of the coefficients are in the lowest possible ratio. What I mean by this step number six is that if you have something, I like to think of this as almost like fractions, right? If you have 2/4 for your fraction, you're not going to leave it as 2/4. You're going to divide both of those numbers by 2 in order to get the lowest possible ratio. So you're going to make that 2/4 into just 1/2. So some tips for balancing these equations, if you have polyatomic ions such as NO3 minus or CO3 2 minus, and they appear on both sides as reactants and products in their ion form, you want to treat them as units. And sometimes you'll see like parentheses around these polyatomic ions with an additional subscript on the end of the parentheses. So if they are like that, treat them as units and it makes it a little bit easier. If water is involved in the reaction, you want to balance hydrogen and oxygen atoms last. And then number three is recount all those atoms after you think the equation is balanced, just to be sure. So let's do our first example as an atomic view so you can really see what's happening here. So here I have hydrogen and oxygen reacting to form water. You can see here that, remember, hydrogen and oxygen are both those diatomic elements, those Brinkelhoff elements, which always are going to exist with two atoms, okay? So here I can see that I have two atoms of hydrogen on the reactant side and I have two on the product side, so we're good with hydrogen. But look, I have two oxygens on the reactant side and only one oxygen on the product side. So I'm going to need another water molecule in order to start balancing this equation. So if I have one more water molecule, I'm good on the oxygen front. So I have two oxygens on the product side, two oxygens on the reactant side. But look at this. Now I have 1, 2, 3, 4 hydrogens on the product side, and I only have two hydrogens on the reactant side. So now I need to also put a 2 coefficient in front of this hydrogen in order to fully balance this equation. And now I'm good. So I have 4 hydrogens on the reactant side, 4 hydrogens on the product side, 2 oxygens on the reactant side, and 2 oxygens on the product side. Now notice how when we're balancing these equations, we put the coefficients in the front of these molecules, right? Now here, even though I only have one oxygen compound, one oxygen molecule, I don't actually put the one right there. So it's almost like that one subscript or the one exponent. You know that it's there, but you don't actually write it down. All right, let's do another problem. So with these, like I told you guys before, I like to actually write the numbers of each atom, each element type under my chemical equation, just so that I can really see how many of each that I have. So here I have silver reacting with hydrogen sulfide. Here, this is Ag is silver. You know, it's kind of weird, but silver is reacting with hydrogen sulfide to form silver sulfide plus hydrogen. So I'm going to add up all of the total number of silvers that I have on each side, the total number of sulfurs I have on each side, and the total number of hydrogens that I have on each side as well. So it looks like I have one silver on my reactant side. I have two silvers on my product side. For hydrogens, I have two hydrogens on my reactant side, and I have two hydrogens on my product side. And then last but not least, for sulfur, I have one sulfur on my reactant side and one sulfur on my product side. So it looks like the hydrogens are balanced and the sulfurs are balanced. So the only thing that I need to balance here is the silver. So I just need to add a 2 coefficient right here in front of the silver, and that will give me 2 silvers like that. All right, so that's another way I like to do this. This is usually how I do it, is I just like to add them up beneath that chemical reaction. All right, so let's balance this. Now, I have copper reacting with sulfur in order to produce copper sulfide right here. So again, let's add up the number of coppers on each side and the number of sulfurs on each side to kind of see what's happening here. So with my coppers, I have one copper on the reactant side, and I have two coppers on the product side. For sulfur, I have one on the reactant side and one sulfur on the product side. So the only thing I need to balance is this copper right here. So since I have two on the side and only one on this side, I'm just going to put a 2 right in front right here. And now I am balanced. I have two coppers on either side and two sulfurs on either side. All right, let's try one that's a little bit harder here. So if I add these up, this is iron right here. I have one iron on my reactant side, two irons on my product side. For oxygens, I have two oxygens on my reactant side and three oxygens on my product side. So now look, we have to balance both of these. Now, the way that I like to attack problems like this is, okay, if I know that I have a compound that's a little bit bigger like this, and I know I'm going to have to balance both of these, I'm going to just put a 2 in front right here and see what happens kind of to my balancing. So if I put a 2 right there, it's going to change both the number of irons and the number of oxygens. All right. Another trick for this is that, do you see how oxygen, this is an odd number right here. Now, because this is an odd number, I need to double that so that it becomes even, because I have an O2 on this side. So you can never have numbers, coefficients that are not whole numbers. They always have to be whole numbers as well. So that's another tip. Now, next, let's change the iron. So we have 4 irons now on this side, because it's 2 times 2 is 4. Since I have 4 irons on this side and only have 1 on this side, all I need to do is put a 4 right there to change that and balance my iron. And then last but not least, I know that I have 6 oxygen on the product side, because 2 times 3 is 6. And then since I have 6 oxygens over here, I need 6 oxygens over here. And since there's 2 in each molecule of oxygen, I just need to put a 3 in front of that in order to get 6 oxygens. And now I am balanced. I have 4 irons on either side and 6 oxygens on either side. All right, let's try this one. We have hydrogen peroxide, that's what this compound is, reacts to form water plus oxygen. Now, it looks like I have 2 hydrogens on my reactant side, 2 hydrogens on my product side, and then I have 2 oxygens on my reactant side and 3 oxygens, because I have 2 plus 1 more on my product side. So I need to change the something over here because I know that my oxygens, right, do not add up. My hydrogens are balanced, but my oxygens are not balanced. So because of that, again, I think I gave this tip on the last example, but if I have one that is an odd number and one that's an even number, I'm going to put my coefficient in front of this right here because I need to make this an even number because this is even over here. And it doesn't matter what I put here, I'm always going to get an even amount of oxygens on this side. So I'm going to put a 2 in front of my water right here. That will change both the number of hydrogens and the number of oxygens on my product side. So if I put a 2 here, I now have 4 hydrogens because 2 times 2 is 4. I also have 4 oxygens because I have 2 here and then plus 2 more. Okay, so 4 hydrogens now and 4 oxygens. And look at this. Now I have 2 on the reactant side and 4 on the product side. So I need to multiply this number by 2 right here. I also have 2 oxygens on the reactant side and 4 on the product side. So I also need to multiply that by 2. So since they're in the same compound, all I do now is put a 2 in front of that, and my hydrogens are balanced and my oxygens are balanced. So there's the answers to all of the ones that we just balanced. You guys are going to do some practice this week and for homework. So let me know if you have any questions. You can always email me with balancing these equations. They can get pretty tricky, all right? So just use the tips, try the examples, let me know if you need any help.